Okay. So we found the domain, which means we set the denominator can't be 0. So it's all real numbers except for 1. That means the vertical asymptote is x equal 1. We then go after the end behavior model. End behavior model is the quotient of the highest powers. It's 2x over x, which is 2. This is a constant. And that means it's horizontal. And it's actually, because it is a number, the actual asymptote is y equal 2. Now what I do with my graph paper at this point, I put in the information that I have. I know that I have a VA. I have a VA at x equal 1. I have an HA at y equal 2. These graphs where you have one VA and one HA are very predictable. They'll either look like 1 over x squared shifted, or they will look like 1 over x shifted. And if we go back to and this is on page 25 of your packet, these are the two graphs that we're talking about. They're either going to be across from each other, pretending this is the VA and that's the HA, or they're going to be, if this is the VA and that's the HA, they're going to be beside each other. They could be going down, or they could be in the opposite quadrants. One VA, one HA, the graphs look like these guys. That means if that's going to be the case, I just need to know where the stupid graph is. To do that, the x-intercepts could be helpful. So that's x-intercepts, is where 2x plus 4 over x minus 1 equals 0. And what's normal with this situation is that normally we would say multiply both sides by the LCD. The denominator goes, I get just the numerator, which is x plus 4 equals 0. And that's the nature of the creature. If I have a fraction equal to 0, the only way it can be 0 is if the numerator is 0. The denominator being 0 sets the domain. The numerator being 0 tells me where the x-intercepts are. And this says that 2x equals negative 4, or x equals negative 2. So it's negative 2, 0, it's where my x-intercept is, and it's right here. Now what does that tell me? That tells me that the graph is in this region. Our graphs in this class don't cross the HA, and they never cross the VA. That says if there is a coordinate point in this new quadrant that's shifted, and this new quadrant, that's where the graph is. The question then becomes, is it a mirror image across this direction, or is it a mirror image side by side? Crisscross, side by side, one or the other. Well, let's go see if the y-intercept, which it's not going to be, by the way. And you're going to say, well, why is that the case? I know the y-intercept is not going to be of any help. Well, the y-intercept is not going to be of any help because this VA is to the right of the y-intercept. So if the y-intercept has to be on this line right here. So that means it's going to be in this quadrant, this lower quadrant. It's got to be. So y-intercept is where x equals 0. That's my favorite. And that's where 2 times 0 plus 4 over 0 minus 1. Anything with x's drop out, you're left with the constants. So it's 4 over minus 1, or minus 4. So it's 0 minus 4. So the y-intercept can be a looking right. X-intercept, usually not. And 0 minus 4, so 1, 2, 3, 4. And that says the graph that I'm looking for on this side is here. The other side, it didn't give me any information about the other side. But I have information, and the information that I have, if I want to look at shortcuts, the information that I have is that the VA is of what multiplicity? If I look, this is x minus 1 to the 1 power. This says that the VA is multiplicity 1. That means odd. That means the arrows are in the opposite direction. So if the left-hand side goes down, the right-hand side goes up, and that tells you the other graph has to be here. If it were multiplicity even, then the two would be side by side. But multiplicity odd on the asymptote is going to put them in opposite directions. Now, if that doesn't make you happy, which I'm sure there's not much that makes you happy, but if it doesn't make you happy, just pull a coordinate point. A coordinate point to the right of 1, like 2. Now, if you evaluate this, I'd have 2 times 2 plus 4 over 2 minus 1, which is 4 plus 4, or 8, over 1, or 8. So that says if x equals 2, y equals 8, the point is up here somewhere. That tells you that's where the graph is. Now we're just sketching. If I wanted a more accurate graph, I'd have to plot more points. But that's what he looks like. That's what he looks like. They're very, very hard to see in your calculator. So that if I were to try to graph this in my calculator, I'd have to be very careful, because I'd have to put the numerator in parentheses because of order of operations, divided by the parentheses in the denominator, and then I'm going to do a zoom standard because I don't know what I did last with my calculator. Now this actually acts fairly nicely in that you can see, indeed, that's where the graph is. You can't really technically see where the asymptote is, but you looks like it's somewhere. It could be 1 or it could be 2, depending. Many times you're going to see that the calculator connects the graph, and in this case it didn't. So that's really kind of interesting that it didn't make the connection, because it drags the pen down and then you'll see this thing come up.